Hello students, this is Mr. Ezra. Today we are going to talk about how to solve rational equations. And in many ways this is going to kind of bring together a lot of things we've talked about with adding fractions and multiplying fractions, and it kind of brings it all together nicely. Puts a little bow on top. It's going to be awesome. Let's get started. All right, so to solve rational equations, if I was to kind of give you some steps for how to do it, the first thing that you always want to do is to identify any undefined values. Remember, these are things that are not possible for x or whatever variable you're using, because if you were to include them, they would cause a divide by zero error. And these are going to get important when we start graphing these functions as well. So it is important when we solve rational equations that we go ahead and identify any undefined values. From there, you kind of have to look at the equation that you have before you decide what to do. For example, if you have a fraction plus or minus a fraction equals another fraction, then you might multiply each of those fractions by the least common multiple. And what this does is it cancels out all the denominators and you don't have fractions anymore. It makes it kind of nice. Or if you end up with a fraction equals a fraction, then sometimes you might cross multiply, and that would get rid of any fractions that you have, and you'd be able to just solve like normal. So once you kind of clean these up, they are pretty easy to solve, like many equations that you solved since middle school. And finally, it is important with rational equations to check your answers. There are occasions where you get an answer algebraically, you did everything right, and you plug it back in, and it just doesn't work because it might cause a divide by zero error or something like that. So you always want to check your answers and make sure that there are no extraneous solutions or that you've done the work correctly. So here's our first example, pretty simple, x plus 8 over x equals 6. First thing I want you to do is to identify anything that x cannot be, and to do that, remember, you just set your denominators equal to 0. So if I set x equal to 0, that means that x can't be 0, because if I had 8 divided by 0, I would end up with a divide by 0 error, and this would be an undefined expression. It would be impossible to move forward. Least common multiple, in this case, there's only one denominator. So this is also called the least common denominator. There's only one, and it's x. So what we're going to do is we're going to multiply everything times x. We're going to multiply x times x, and 8 over x times x, and 6 times x. All of the parts, everything gets multiplied by x, and we do that because this x right here and this x right here cancel each other out. So I no longer have any fractions. I just have a quadratic, because x times x is x squared plus 8 equals 6x. Now when you have a quadratic, you want to get everything on one side of the equal sign. So we're going to say x squared. We're going to subtract this 6x to the left, and then the plus 8 goes at the end to put it in descending order. All right, so now we're going to factor this guy right here, and to factor it, we know that x times x is x squared. Factors of 8 that add to give you -6 would be -4 and -2, because -4 times -2 is +8, but -4x minus 2x is -6x. That means that the two solutions are +4 and +2. And I want to plug those back in up here, make sure that they work. So 4 plus 8 divided by 4 is 6. That's correct. 2 plus 8 divided by 2 is what? 2 plus 4, which is 6. That works as well. So since both of them work, these are the two solutions, 4 and 2. All right, example 2. So first off, we want to make sure that we list our excluded values by looking at the denominators. I see a 3 here. There's no variables, so no excluded value for that fraction. X can't be 0 here, because if it were 0, we would have a divide by 0 error. Now, this least common multiple of the denominator, also called the least common denominator, is 3 times x, or 3x. So what we're going to do is take each of these fractions and multiply that fraction by 3x. So we got 10 over 3 times 3x, 4 over x times 3x, plus 2 times 3x. Every part gets multiplied by 3x. Now, what we're really doing is multiplying the left side and the right side of the equal sign by the same thing. is a way to solve an equation. We don't usually do it this way, but in this way, we're not only getting closer to solving the equation, but we're getting rid of the denominators. And what you'll notice is, like, for example, here, this 3 and this 3 will cancel out, leaving us with 10x. In this next fraction, this x will cancel out with this x, leaving us with 4 times 3, which is 12. And then 2 times 3x is positive 6x. Now we're just going to solve this equation using collecting like terms, collecting variables to one side, constants to the other, dividing, and it's just pretty simple. So I'm going to subtract 6x on both sides, subtract 6x here, cancels out, right? Subtract 6x over here, I've got 4x equals 12. Divide both sides by 4 to get x equals 3. And 4/3 plus 2 is 10/3. And also, I'm just going to check and make sure my excluded value is x can't be 0. Well, I got x equals 3. That's not 0, so I'm good to go. That is my answer. All right. Now, in example 3, we have a fraction equals a fraction. And if you look at those steps of how I mentioned that you should solve these, I said you would cross multiply. But pay attention here. We notice that this denominator and the denominator on the right are exactly the same. And since that is the case, since we know that they're the same, we're simply going to set the numerators equal to one another. Since the denominators are the same, we can just set the numerators equal to each other and then solve. Okay. Now, what was the excluded value for x? What can x not be? Well, if basically you take your denominator, in this case x minus 3, and you set it equal to 0, and solve, right? So we got x equals 3 would cause a 0 in the denominator. That means that x cannot be 3. Right? So x can't be 3, it could be anything else but 3. Then we begin to solve this. So in order to solve this, I'm going to subtract 2x. This is called collecting variable terms to one side of the equal sign. 3x minus 2x is x. And in fact, I get x equals 3. Well, if I try to plug this 3 in, 3 times 3 divided by 3 minus 3 is 9 divided by 0. Right? And what happens when you try to divide 9 by 0? You end up with divide by 0 error. It's undefined. It can't be 3, right? So this is called an extraneous solution. It worked algebraically. We got 3, but when we plugged it back in, it was one of those values for x that we cannot use. So in fact, since the only solution that we got was extraneous, we will actually say that this question has no solution, not one possible. Example 4. Here we have fraction plus fraction. And remember, when we have fraction plus fraction, we want to find the least common denominator or the least common multiple. Now, x can't be positive 1 because 1 minus 1 would be 0. Remember, you can just set that denominator equal to 0 and solve. We get 1's not possible here or here. If there's no variable in the denominator, we don't have to worry about excluded values. Now, the least common multiple, we're going to use the 6 as well as the x minus 1. The 6 as well as the x minus 1. And remember, when we have fractions plus fractions in our question, we're going to multiply all of the parts times that least common multiple. So we're going to multiply times 6 times x minus 1 for every fraction in the question. Again, times 6 times x minus 1. Do not distribute the 6 into the x minus 1. Keep it separated. Because some of it's going to allow us to reduce all these fractions and get rid of the denominators. Okay, so x minus 1 is going to cancel out with x minus 1 here and here. And 6 is going to cancel out with 6 there, which leaves us with 1 times 6 equals x times 6 plus x times x minus 1. And I'm going to go ahead and distribute that to give me x squared minus x. Go ahead and multiply x into x minus 1. I've got a quadratic, so I want to get everything together on one side of the equal sign. Since I like for my leading coefficient to be positive 1 here, positive 1x squared, I'm going to basically subtract 6 to the right side of the equal sign, and then combine my like terms and put in descending order. Right, so I've got 0 over here, and then I'll put the x squared first, using the commutative property of addition. I've got 6x minus x is positive 5x, and then minus 6. I want to factor this. So I've got x times x is x squared. It looks like it's going to be plus 6 and minus 1 to multiply 6 times negative 1 to get negative 6. But the inside and outside products add to give you 5x, which gives us potential solutions of negative 6 and positive 1. Well, remember that 1 is a limitation. We can't use that. It would cause an divide by 0 error. It would be undefined at 1, which means that this 1 here, not a solution. Wouldn't work. When you plug it back in, 1 minus 1 is 0. You can't divide by 0. It gives you problems. The negative 6, on the other hand, is perfectly fine. If you plug it in and do the math, it will work out perfectly. So the lesson here is always check your values for x that are undefined, things you can't use, because sometimes algebraically you get there. Well, just because you get there doesn't mean it's the solution, doesn't mean it actually works. Example 5. Here we have fraction equals fraction and the denominators are different. So in this case, the easiest way to handle this is going to be to cross multiply. What we're going to do is take this x and multiply it times x minus 4 equals, and we'll take this x and multiply it times x plus 1. So we're going to distribute x into x minus 4 and x into x plus 1, and then we'll solve from there. So x times x is x squared, and then minus 4x when you distribute the x. And on the right side of the equal sign, we get x squared plus 1x, or x squared plus x. Now, I try to subtract in a way where my leading coefficient is going to be positive, but what's going to happen when I collect my x squareds to one side of the equal sign here is they're going to cancel out on both sides, leaving me with negative 4x equals x. Well, I still have to collect my x's to one side of the equal sign, so it doesn't really matter which way I do that. Guess I will subtract x to the left, collect those variables in that direction. Well, x minus x is, in fact, 0, and negative 4 minus 1 is negative 5, and I still have to divide by negative 5 here. And 0 divided by anything is 0, so I get x equals 0. Now, I forgot something important, so let's go back and do it. What are the limitations on the domain? Well, I can't have negative 1, because that would cause a divide by 0 error on the left. I can't use positive 4, because that would cause a divide by 0 error on the right. It looks like 0 is not either of those numbers, and if I plug it in, I'll end up with 0 equals 0, which works. So that is, in fact, the solution. All right, that's it for today. As you're practicing, if you run into anything that you didn't see in the videos, please raise your hand, call me over, talk to me, and we'll get it figured out. But that's pretty much it. Quick and easy way to solve rational equations. Have a great day, and I'll see you in class.